Welcome to slide pack 2 of the financial modeling program. In this slide pack, we'll basically go through some financial and business math. Now, one of the most important formulas in financial modeling is net present value, that basically tries to determine what the value is today of a series of future cash flow payments. And net present value exists because money in your hand today is worth a lot more than a promise that someone's going to give you money 5 years from now or 10 years from now. So if someone says, give me $1,000 today and I'll just give you $1,000 5 years from now or 10 years from now, you might say yes. But the reality is what you can buy with that $1,000 today because of inflation would be a lot more today than 5 years from now. So you need to protect yourself against inflation, and businesses also understand that money loses value over time, or the risk of getting money 5 years from now needs to be factored in. And there are instances where someone takes money from a business and just does not pay. So factoring all of that in is something that the net present value formula does reasonably well. So if we take an example here, if you take $1,000 and let's just say it's $1,000 that you get 10 years from today, what do you think that value will be today? Per the NPV formula, what you do is you take the $1,000 and you divide it by a factor that basically looks at a discount rate, and it compounds it by 10 years in this case. Now, the caret that's been used here is essentially a mathematical expression for to the power of. So, for example, 10 to the power of 2 is 100. And you can express this with 10 in parentheses and a caret sign and the number 2 next to it. And by the way, this is a formula that also works in Excel. So if you have 10 in parentheses with a caret sign, which is essentially an inverted V sign, and you have the number 2 next to it, then Excel knows that you're essentially trying to do 10 to the power of 2, which is 10 times 10, which is 100. Likewise, you can actually do to the power of fractional values. So if you do 100 to the power of 0.5, Excel will tell you that the answer is 10. So the N in the formula is essentially the discount period, which can be years, months, or days. Now coming back to our $1,000 example 10 years from today, the value of that money today is only $781. And that is purely factoring in inflation. Now just what if that person changes his mind or decides not to pay you? So there are additional risk factors that you need to also factor in. So beyond inflation, if you factor in other things like perhaps the risk of default, the real value of $1,000 is probably not even $781. It might just be closer to $500. Now, in that formula, the NPV formula that we just saw, R was the discount rate. And the discount rate basically is a measure of the risk involved with a certain amount of money over time. And R is actually calculated as the sum of various risks. So for example, there's a rate of inflation that's R sub inflation, there might be a default risk, which is R sub default, and so on and so forth. Now, when you're doing valuations of companies, you have to consider various risk items like the size of the company, the liquidity of stock in that company's credit rating, things like that. So with a larger company like a Microsoft or a Walmart or a General Electric, chances are 5 years from now the company will be around to honor its commitments. But if it's a small company that's, let's say, been started up by a couple of people in a garage, they might not be around 5 years from now. Or even if they are around, they may not have the cash to pay you, and they might say they'd pay you in stock. But you cannot turn around and readily sell that stock in the market, whereas with a GE or a Microsoft, you can take shares and immediately flip them in the market for cash. Likewise, credit rating is another risk factor. A company might have a AAA credit rating, whereas another company might have a single A credit rating. And a credit rating basically calculates a lot of factors, but is a proxy for the company's ability to meet its various obligations. So this R is a discount rate that actually includes a lot of risk factors on a payment stream and needs to be arrived at and thought through very carefully. Now, you need to match the time periods for the rate of return and the discounting time factor. So if someone says that you can apply a 12% discount rate, what they mean is 12% per year. Alternately, someone can say, you know what, I need money from you for 5 months, and why don't you apply a discount rate of 1% per month? So when you do your NPV formula, you've got to make sure that if you use the annual rate, which is percentage per year, then you've got to discount your time in years, which is annual compounding. On the flip side, if someone says 1% for 15 months, then you've got to use 1% for your R, and you've got to use to the power of 15. So your rate is 1% per month and your time is 15 months. So you always must make sure that you match the time periods for your rate and for N. Now this is just an example to show you that there is a difference between annual and monthly compounding. Now, when you're dealing with small amounts of money, it may not be that important, but when you deal in the millions or even the billions, as a lot of companies do, then monthly versus annual compounding actually does make a material difference in the amount of interest or in the net present value. So what we have here is $1,000 20 years from now, discounted at a rate of 12%. When you do annual compounding, the net present value of that $1,000 today is $104. But when you consider the same with monthly discounting at 1% for 20 years, which is 240 months, 12 months in every year, you get a net present value of only $91.8. So monthly compounding tends to be a lot more expensive than annual compounding. And with monthly compounding, the interest that is due every month, if it's not paid, it's added to your principal and you start to accumulate interest upon interest, which is what happens with your credit card bills. If you do not pay your bills on time, they're added to your next month's tab and they accrue interest. So you've got to decide what makes sense in the valuation or the NPV that you are doing. Perhaps it makes sense to value something monthly, or perhaps it makes more sense to value it annually. But I just wanted you to know that there is a difference between annual and monthly compounding, and you must use what you believe is the right time frame. Now, discount factor is basically just the factor by which you discount a certain cash flow. So it's 1 divided by 1 plus r to the power of n. So in our NPV example, where you have $1,000 that's being discounted at a certain rate for 10 years, and the rate here is the inflation rate of 2.5%, take out the $1,000 and what you're left is 1 divided by 1.025 to the power of 10, which mathematically equals 0.781, and this 0.781 is your discount factor. Just as we spoke of net present value, there's another term which is called the future value of money. In other words, if you give someone $1,000 today, how much would you want from him, say 10 years from now, to compensate you for perhaps investments you could have made with that $1,000 somewhere else, such as stocks or bonds or businesses or whatever? So the future value formula essentially is the principal amount multiplied by 1 plus r to the power n. So for example, the future value of $1,000 would be 1,000 into 1 plus 0.1, which is 10%, raised to the power of 10. So in other words, if you give someone $1,000 today, you'd want him to give you $2,593 10 years from now, based on your assumption that that $1,000 could have been invested by you somewhere else at a 10% rate. Now, in financial modeling, we typically model multiple cash flow streams. So, as you'll see, there are cash flows in year 1, year 2, year 3, year 4, year 5 of your financial projections. And these multiple cash flow streams need to be valued, let's just say, to give you the net present value today. Or to take a different example, let's say your friend borrows some money from you today and promises to pay you $1,000 in 3 equal installments 1 year from now, the second one 2 years from now, and the third one 3 years from now at a 10% discount rate. Then the net present value of the first payment is 1,000 divided by 1.1, which is $909. The net present value of the second payment is 1,000 divided by 1.1, but to the power of 2, because it occurs at the end of the second year. And that has a value of 826. And likewise, the third payment, which occurs 3 years from now, is 1,000 divided by 1.1 to the power of 3, which is $751. And when you add all of them together, the net present value of these 3 $1,000 cash streams is $2,387 at a 10% discount rate. And what we have on the slide is how this NPV would be mathematically expressed. And when you've got $1,000 or the same amount of payment occurring at the end of each period, you can essentially take that out as a common amount, and what you have is a sum of the discount factors for 1 year, 2 years, and 3 years. So this NPV formula is essentially the basis for a discounted cash flow valuation. Now, practically speaking, when you project financials, let's just say you're doing annual projections, you will project cash flow streams that happen at the end of the first year and the end of the second year or the end of the quarter. But in reality, A business operates all year round and it has money coming in all year round. So as opposed to saying that all that money is going to come to me on the 31st of December, a lot of times business managers prefer to use a mid-period assumption, and they say, you know what, let's just assume that this money comes to us in the middle of the year and we will just discount it from today to the middle of the year. So as a result, they have discount factors that are to the power of 0.5, which represents half a year or 6 months, or 1.5 for a year and a half, or 2.5 for 2.5 years. So make sure you speak to your stakeholders and determine whether mid-period discounting makes sense or whether end-of-period discounting makes sense. In cases where you're doing a valuation of cash flows at the end of every month, perhaps it's okay to go with end-of-month discounting. But if you're doing it at the end of every year, then perhaps midstream accounting makes more sense, or mid-period accounting, or discounting. Now, another important financial formula is the internal rate of return. And let's illustrate this with an example. Let's just say that you have a certain amount of money that needs to be invested, and you know that there's a fixed dollar amount that you need to put in today, and that you are going to get a series of profits from operating this machine for the next 5, 10, or 20 years. Alternately, you could put that money into stocks or bonds or something else. So how do you determine if you're better off putting that money into the machine, or if you're better off putting it into, say, a bond that gives you a certain rate of interest? You figure it out essentially by using the NPV formula, where you know that the net present value is the amount of money you've got to put in to buying that machine today. You also know what your future cash flows are going to be and when they'll happen. What you do not know is the rate of discount. And when you mathematically calculate this rate of discount is called the internal rate of return for this project. And if you compare the internal rate of return for multiple projects, you may have some sense of what project makes more sense purely from an investment perspective. But that said, another project with a lower IRR sometimes may make more sense from a strategic or a business perspective. So the IRR, again, is a handy tool, but it's not always the final decider on how you make a certain investment. So make sure you sort of think about other factors in this decision making. So that's the end of the second slide pack. Thank you very much.